For our project, we wanted to create a robotic arm that was capable of picking up and moving small containers. In particular, we wanted the arm to be used to pick up and move containers containing dangerous chemicals that were harmful to humans. In order to accomplish this, we designed the robotic arm so that the upper arm and forearm were made up of two 4-bar mechanisms. The use of two 4-bars allowed the arm to have more maneuverability while still retaining a long extension and reach. At the end of the forearm are the wrist link and the claw. The two parts of the arm were driven by a stepper motor and a servo, while the wrist and claw were driven using servos. The robotic arm also makes use of an FSR and a gyro sensor. The FSR, or force sensitive resistor, was used so that the claw would automatically stop closing around the container and would continue to keep a firm grip while the arm moved around. The gyro was used so the wrist link would rotate as the upper arm and forearm moved. This is so that even as the arm rotates, the wrist and container stay parallel to the ground. This is necessary so that the container would not spill its dangerous chemical contents. The entire arm also has a NEMA 17 stepper motor attached to the bottom of the base that allows the arm to rotate. The upper arm is driven using the NEMA 17 stepper motor with a 51:1 planetary gearbox, which has an output torque of 6 Nm. The stepper motor is controlled using an A4988 motor driver. The forearm is controlled using a Luan Sol digital servo, which has 180 degrees of rotation and has an output torque of 2 Nm. This is connected directly to the Arduino. The wrist link is controlled using a Hitek servo, which has an output torque of 0.49 Nm. The code was designed so that as the gyro registered a change in pitch, the servo would rotate the wrist the correct steps in order to offset the change in pitch and keep the wrist and container parallel to the ground. The claw is opened and closed using a GW servo, which has an output torque of 0.49 Nm. The claw was coded so that once the closed claw state was activated, the servo would rotate and close the claw until the FSR returned a desired set value of 1000. Once this happened, the claw would stop closing. The code would continue to run in the background and while the arm is in the closed claw state. If the FSR returned a value below 1000, the servo would start to rotate and try to close the claw until the FSR once again returned the desired value of 1000.